In this video, we're going to take a look at z-scores and just get some practice calculating z-scores and thinking about them. One of the things that's most helpful about z-scores is it helps us to compare data values that come from different distributions, so distributions that have a different mean and a different standard deviation. Let's hop into our example. So suppose that SAT scores are nearly normally distributed with a mean of 1,500 and a standard deviation of 300. So let's just pause here and make a note of some of these things. We're going to talk about SAT scores, and then in just a second we're going to talk about ACT scores. So for our SAT scores, we know that the mean is equal to 1,500 and the standard deviation is equal to 300. Let's just make a note of that because we're going to come back to it in just a moment. We also have ACT scores are distributed nearly normally with a mean of 21 and a standard deviation of 5. So for our ACT scores, the mean of this distribution is 21 and a standard deviation of 5. So we have these different distributions. They both happen to be nearly normal, which is good. That means that it's easier to compare them. But we still need to do a little bit of work here because they have different means and different standard deviations, so it's difficult to compare data values that come from these distributions against each other. So we have a college admissions officer. A college admissions officer wants to determine which of the two applicants scored better on their standardized tests with respect to the other test takers. We've got Anna, who earned an 1,800 on her SAT, or Ryan, who scored a 24 on his ACT. So we have these two different test scores. These are our observations. These come from the real world. So in the z-score formula that we're going to see in a minute, we often use x. We use x as the variable for our observation. So Anna scored an 1,800 on her SAT, and then Ryan scored a 24 on his ACT. So I have these different scores that come from these different distributions. Let's go ahead and find the z-scores corresponding to them so that we can compare. So now we're going to find the z-score. So in both cases, I know my z-score formula is x minus the mean divided by my standard deviation. The mean and the standard deviation hopefully are pretty self-explanatory, but x is our observation. That's that real-world data value. So in this case, if I'm looking at the SAT scores, that would be on a score of 1,800. So if I look at this, I have 1,800 minus my mean is 1,500 divided by my standard deviation of 300. And if we remember order of operations first, we're going to subtract the numerator, so I should have 300 divided by 300, which gives me, exactly 1. So my z-score is equal to 1. So my z-score is 1. Then I'm going to compare that against the ACT scores over here. So using the exact same formula, but in this case, my mean and my standard deviation are going to be a little bit different. So my z-score over here again is x minus the mean divided by my standard deviation. So my z-score is 24 minus 21 divided by 5. So I have 3 over 5 simplifies to be, if we wanted a decimal, 0.6 is our z-score. So here we've got the z-score for Anna. Over here we'll highlight that in blue, and then the z-score for Ryan over here on the right will highlight that in red. So if I'm comparing these two, the one with the higher z-score tended to score better than the other test takers on their test. And if what this means is, if I was to graph this on my standard normal distribution, which is where my z-scores live, the mean on a standard normal distribution is always 0, and then the standard deviation is 1. So if I was to plot these 2 points, I've got Anna's score over here is 1, and then Ryan's score over here is still to the right of the mean. It's still kind of greater than the average, but it's not quite as high compared to the other test takers. It would be sitting over here at 0.6. So if I wanted to know which of these scores is higher compared to the other test takers, I'm just going to take simply the one with the higher z-score. So I would be taking Anna's test